Hey everyone, this is Wolfman29. My name's Sam, by the way, for those who aren't aware. So here's a little video of my build, demonstrating the driver, the build, the setup, everything like that. So here we have the main driver. I'm covering up the IC name because I use it for Blitz Linear as well. See those little 7 chips lined up over here? Those are the sort of homebrew analog to digital or digital to analog converter. It basically uses a series of 7 analog switches, which works really nicely. If we go in a little bit closer, that big resistor there is a sense resistor. I have a little MOSFET there. Sorry, it's kind of messy and my camera's crappy. That little IC there above the big one is the Schmitt trigger, and I had to use that in order to debounce the button presses, because when you press a button, it actually clicks on and off a few hundred times in a short time before it actually settles in one position. So I needed to remove that, because otherwise clicking a button basically reset my counter, and my counter determines how powerful the laser is, which we don't want that to be randomly going. You'll notice a little red wire coming off from the IC. That's because when changing out the IC, because the one I was using was fried or something, one of the pads got ripped off, so I just, it wasn't a very important lead, it was just connecting to a resistor. I mean, nothing high power, nothing like that. So just some minor changes. I didn't want to have to reflow the whole thing just in case some of the parts broke. Anyway, I'm gonna put this together and show you guys that it works for a proof of concept. So it fits in right there. The C mount is going to go here-ish. There's enough room for a pretty beefy heatsink here. I'm gonna have a lens sit out here. There's a little red thing that I'm gonna put the lens in. So I'll have a good 2 inches or so. So here is the other side. It screws directly on. I'm not really worrying about arrangement right now, because it's just a demo. So I'm just gonna screw. I guess I'll just direct this at me for now. I'm just gonna screw in the or reassemble the phaser really quick. Sorry for the crappy quality of the film. It's my iPad camera, or my iPod camera. Anyway, 1 screw should do enough. So this is what the phaser looks like when it's assembled. There's a little red thing that comes out here. I didn't put it in because I needed room to put the leads to the test load. I have the test load set for it's just reading off of the 1 ohm resistor. There's no actual diode there. It works fine when there's a diode there. It's just it requires a higher forward voltage. And when we are when I'm driving something at nearly 3 amps, that resistor alone is going to be dropping 3 volts. So because these red diodes drop like 2.5 volts or so, or 2.5 to 3, I figured that a 1 ohm resistor would be best. I mean, it's not the best simulation, but it'll do. Anyway, so I haven't figured out yet how to get the other one in there, the other battery in there. I'm using two 14500s. They're IMRs. They're wired in parallel. I just need to make a little bit of room for the other side because it wasn't originally built to be in parallel. It was built to be in series. So I'm just going to plop this in. Here's a multimeter. I'm going to put it on to 20 so it can read. Obviously, it's not reading anything right now. So I'm just going to plop that battery into one of those slots. If I can. Well, if I can do this with one hand. This shouldn't be this hard. Okay, there we go. So it doesn't actually fully fit. I'll have to get some batteries that actually fully fit. Anyway, just turning this around so then it is so I can display what I'm doing. So here's me pressing the button now. You'll notice that when it first starts on, the output power is essentially 0. I mean, there's a small amount of resistance that generates small voltage, but it's like outputting 15 milliamps. It's basically off. I mean, it's nothing. So now you'll also notice that the button is independent. These buttons are independently powered. So this will turn on the laser. This will increase the power. This will decrease the power. But the on button does not need to be pressed in order to do that. So I'm going to pop it up 2 levels by clicking the up button twice. That should increase it to like 900 milliamps or so. So let's take a look. And on it goes. There, 930. Now I can pop it up while it's on. It's just a little bit harder to do. So now it's at 1.27. If I pop it up again, it's at 1.66. I can decrease it There we. Let me turn it off and decrease it. Decrease it. There you go. Decrease it again. Increase it. Increase it. Ah, my thumb's not very good at this. Yeah. The driver's functioning. I'm just, you know what? I'll just use two fingers. So it's on at 1.6. Increase it again, 1.95. Increase it again, 2.28. And increase it again, 2.48. Right now, that's about the maximum that my battery can supply. So this is not a driver issue. When I power it with a lithium with an 18650, it easily spits out 2.8 something amps. So and if I increase it once more, it drops down to 0. So it's nice. It cycles. It has various power modes. Sometimes the low button doesn't seem to like cooperating very often. See. Oh, it cooperated that time. You can also cycle backwards too. So I guess that's my little demo of the Phaser. You know, it's a linear driver, but you know, at 4.2 volts and at somewhere between 3.3 and 4.2 volts in, you know, dropping, I don't know, a volt or so, it's not very inefficient. Anyway, I hope you guys liked the video. Thanks for watching. I'll try to put this up, and proof of concept works. Now I just need the heatsink and the diode.